In the design layouts where it is going to preserve part of the structure of the old roadbeds, the reinforcements are defined. This video will show how to apply them using MDT. For this, it is necessary to have created the segment that defines the new layout and to have drawn and planned the limits that will define the reinforcement. Two open polylines that delimit the reinforcement on each side of the horizontal alignment and along it, usually coinciding with the edges of the old pavement. It is also important to take into account the following premise. In MDT, utilities, configuration. On the cross-sections button, the area to be reinforced is delimited by the pavement code on the cross-section, and the part in which the clearing will not be cleared is delimited by the topsoil code. Since both parts usually are the same, the pavement or road surface is not usually cleared. Both codes must be the same so that if clearing is defined, it is not applied in the reinforcement area. It is left in both codes, PV. Except. Now through MDT, road segments, create edit. The template is edited and the same is defined in the reinforcement tab. First of all, the Apply Reinforcement box is activated. With the Layers button, the roadbed to be applied to it is defined. In this example, the same one that has been defined in the structure of the pavement is going to be applied. Press Copy from roadbed, and the structure show up. Accepted. Next, the limits of the reinforcement will be defined. Below, click on Select Polylines, and select the two polylines along which and between which the reinforcement will be applied. After that, the projection of the same in the cross-section is marked in the window, between which the reinforcement will be applied. Next, the maximum tolerance is defined. This value must be greater than the difference between the elevations in the natural terrain and the subbase at the edge of the reinforcement. The value depends on the geology of the natural terrain. Normally, similar values are applied to the roadbed or higher to include cut area where the new vertical alignment is lower than the existing terrain and it is possible to keep the last layers of the old pavement. Adjust to terrain is usually activated so as not to differentiate the volume in the area to be reinforced in embankment. Finally, desired a minimum thickness is specified for the sections in which the future pavement is below the current terrain. Cut section, in which this indicated thickness is going to be milled, scarified, or eliminated so that a layer can enter complete across the width. In this example we indicate 6 cm corresponding to the last two bituminous layers, and thus in the paving phase they will be applied for the entire width of the platform. Once defined, you can see how the reinforcement is applied along the road in Station 0. When zooming in the reinforcement marks, it is verified that the program calculates the height between the natural terrain and the subbase on both sides. It is inside the roadbed and it is less than the maximum tolerance, therefore it applies reinforcement, and it adapts to the terrain. Continuing along the route, reinforcement is applied in this embankment area up to Station 50, where the subbase is already above the natural terrain. Go back to Station 45 a few times to see the difference. Station by station is continued up to 120 where starts cut section. A window is zoomed in and it is verified that it is on tolerance and is inside the roadbed. It continues and it can be seen in this cut area. For example, in PK 140, when zooming in, the reinforcement adapts to the platform and leaves a minimum thickness of 6 cm for the bituminous layers to enter the paving phase. At the next station 145, reinforcement is no longer applied since the distance between the natural terrain and the subbase is greater than the 0.7 meters indicated in the maximum tolerance. A cut section where it is already necessary to remove the entire template. And so on throughout the road. The reinforcement is applied in the area of action marked by the two polyline SIF. It's on tolerance and it is within road bed both on embankment and cut area, adapting to the terrain or final platform while preserving a minimum thickness if necessary.